Alright guys, so the first couple that we're going to talk about are kind of our special cases for what we're doing today, okay? Kites and rhombuses. So the area of a rhombus or a kite with diagonals D1 and D2 is 1/2 D1, D2. So 1/2 times the first diagonal times the second diagonal. Okay, so on this rhombus over here, we have a diagonal of 8 meters and a diagonal of 6 meters. So what's my formula here? 1/2 D1, D2, right, which happens to be on this case, 1/2 D1, D2, 8 times 6, 1/2 of 8 is 4, 4 times 6 equals 24. So the area for this rhombus is 24 meters squared. Okay, how are you going to set up that next one? What kind of shape is that? Kite, right? So Joe, how would you set this one up? 1/2 times 7 times 10, right? That goes back to our 1/2 D1, D2 formula. Since multiplication is commutative, if I'm doing this in my head, I'm probably going to switch these two around. So I have 1/2 times 10 times 7. I know 1/2 of 10 is 5. So I really have 5 times 7. What's 5 times 7? 35. And what are my units here? Centimeters squared. Exactly. Okay. Pretty straightforward, right? 1/2 the first diagonal times the second diagonal.
Okay, you can add that to the list of formulas that we know how to find the area. All right. The second part of this lesson is talking about finding the area of regular polygons. Okay, regular meaning all the sides and all the angles are the same. Polygon meaning it's got a certain number of sides. So a regular pentagon, hexagon, decagon, octagon, and so on and so forth. Okay, a couple things we need to understand before we dive into that. All right, we're going to learn something called the apothem. And the apothem is the distance from the center of a regular polygon to any side. And we're going to do this. I want you to put shortest. It's the shortest distance from the center to a side of a polygon. Now, when I say shortest distance, again, if I'm a point standing in space and I want to find the shortest distance to that back wall, everyone always says straight, but if I go to the corner, isn't that a straight line? Yeah. It's a perpendicular line. So if I want to walk to that back wall and I want to walk the shortest distance because I'm really lazy, I'm going to walk a line that is perpendicular to that wall. Okay? And I'll show you an apothem here in just a second. The central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices of a polygon. So if I scroll down here to the picture, I'll scroll back up in here a second. The apothem would be segment FG. Okay, let me go back. I have a pentagon here. It says a regular pentagon in the directions, and it is inscribed in circle F. Okay, that's why I've got the circle around it. Part of the reason there's a circle around it because I want you guys to understand that the radius of the circle is the same thing as the radius of the polygon. Do you guys see that? So the red lines, FB and FA, those would be the radius of the circle, which are also what we call the radius of the polygon. Okay, they're the same thing. The blue line, FG, that is what we call the apothem. It goes from the center of the figure to a side, and it's the shortest distance. It's going to be perpendicular to the side of the shape. Okay, what else do we need? Oh, central angle. Okay, central angle would be like this angle right there. Again, central angle of a circle, but central angle of a polygon is different because a central angle is created by two radii, the red lines, and consecutive vertices. Okay? So to find that central angle, what are we going to do? If I want to find that angle, how can I do that? Here's another question. How many of those angles are there going to be inside this pentagon?
5.
Why 5, Joe?
Because there's 5. Then
Aren't there 5 sides? So each side essentially creates, don't draw this, it'll get too crazy, but each side creates a central angle. So to find out the central angle of a polygon, take 360 and divide it by the number of sides. Okay, so again, going back to this picture, I know that this central angle, there's going to be 5 of those central angles in this pentagon. Guys, if I have a decagon, how many central angles are there going to be? 10. Decagon's 10. Okay, let's go over those. 5 sides is pentagon. 6. Hexagon. 7. Heptagon. 8. Octagon. 9. Nonagon. 10. Decagon. Skip 11. 12. Dodecagon. We start with 13 when it talks about this 13gon. Okay, so to answer this question, it says we need to find the measure of angle AFB. AFB. Well, that's that central angle. And I know there's going to be 5 of those. So 360 divided by 5. What do you get, Dean?
72.
72 degrees. All right, now I want to find AFG. Angle AFG, that angle right there. Any ideas there, Jaden? None. Okay. Chris, ideas?
Well, angle line FG is the bisector, so we could just divide the 72 degrees by 2.
Yeah. This apothem, the blue line, the apothem, is going to cut our central angle in half. So if our central angle was 72, well, AFG right here is going to be half of that, which is 36. Okay, and then we need to find GAF. GAF is going to be right there. Cam, how are we going to do that?
I did 180 minus 90 minus 36. Get that triangle.
Oh, you're looking at this triangle, right? That's one way to do it. We already said that that's 36. I know that that's 90. So 180 minus 90 minus 36, what does that get you? 54. Is there another way to do that? Joe?
180 minus 72 divided by 2.
Okay, the central angle, if I look at this triangle, the central angle is 72. So 180 minus 72. I know this is an isosceles triangle because those are both radius of the circle. Radiuses or radii of the circle. So then I can take 180 minus 72 and divide that by 2. Any questions there about applying or using the what the apothem is or finding the central angle of a polygon?
So here's the basic idea today, going all the way back to the kites and the rhombuses. The area of a regular polygon is just going to be the area of one triangle inside of it times the number of triangles. So in each of these shapes, we could split it up into a triangle, or into a bunch of different triangles, right? So if we can find the area of one of them, we can just times it by the number of triangles inside of that shape to get the entire area. Okay? So the area of a regular n-gon, okay, we're going general here, any n-gon with side length s is the product, or sorry, is 1/2 the product of the apothem A and the perimeter P. Okay, we have two ways we can write that. The first one is exactly how they just gave it to us there. 1/2 A, which is our apothem, times P, the perimeter. Okay, you probably won't use that one much, but perimeter. How can we find the perimeter of that shape if we're just looking at the different side lengths? Chris, what do you think?
6s.
Yeah, on this one it would be 6s, right? Because there's 6 sides. So the idea there is 1/2 your apothem again. But instead of timesing by the perimeter, split the perimeter up into what it is. Just like Chris just said, it's our side length, S, times the number of sides. So that's side length. That's number of sides. Remember, our apothem is A.
Guys, before or up at the top, Mr. Wentz said the area of one triangle times the number of triangles. I want you to understand. If I were to find the area of this triangle right here, well, we just said before class started, 1/2 the base times the height. What's the base of this triangle? S. What's the height of the triangle? A. So it's 1/2 S times A, 1/2 A times S times however many triangles there are, and that's n. So that's kind of where this formula comes from. Hey, we're going to find the area of one triangle, and we're going to times it by the number of triangles inside that polygon.
All right, let's look at an example. We have a pentagon. How many sides is a pentagon again? 5. Okay, so our number of sides here is, sorry, that's our n, is going to be 5. Okay? Do we know our side length? Not yet, do we? We know the apothem though, right? What's our apothem on this one? 6.5, right? It's the height of this little triangle here. 6.5. Okay, so all we're missing is our side length. How do you guys think we could find that? Allie, what do you think?
You could do 6.5 squared times, you could just put like x squared equals a squared.
X.
And then you would find like the base of that little triangle and then you can multiply that by 2.
Say that again?
Kind of like you do 6.5 squared plus and then whatever the base of the triangle is and I just said x.
So you're calling this x, kind of, right?
Equals 8 squared.
I absolutely agree. What did she do here, guys? Pythagorean theorem, exactly. Right? We have two pieces of that right triangle. We have the 8 squared part, the hypotenuse, and we have that height, the 6.5 squared. Okay, so we just need that other side squared. If we're going to solve this, we're going to have x squared equals, we want to subtract 6.5 squared, right? Get x squared by itself. Okay, that's going to give me 64 minus, anybody have 6.5 squared? What is it? 42.25. Awesome. So x squared equals 64 minus 42.25. What was it? 21.75. And then we've got to square root that, right? Get it all by itself. So our x is going to give us 4.66. Round it to the hundredth place, right? Be 4.66. Okay, so is that our side length? No, right? We need to take that times 2 because we found half of this side length. We need to find this part too. Okay, so since we found half of it, we can take our x times 2 here. That's going to give us 9.33. Okay. And then since we have our side length, we can plug it into our formula, right? Area equals 1/2 the apothem times the number of sides times the side length. Area equals 1/2. We said our apothem is 6.5. Our number of sides is 5. Our side length is 9.33. When you multiply that all together, what do you get?
3.22.
Say that louder. 303.23. I think that's a little high. Yeah. 151.61. I think that's right.
It is, you could times it by 0.5. Sure. Easy to do, guys.
156 point or 151 point what again? 661. Thank you. Okay. So the area of that pentagon is 151.61 units squared. Okay. Let's try that again. So we have a nonagon. How many sides does a nonagon have? 9, right? So our n is going to be 9. Okay. Do we have the apothem or the side length? No, right? We have a radius, but that doesn't really help us with our formula. Let's zoom in real quick here, okay? I'm going to draw this triangle. Okay, if I fill in what I have, I know that's my right angle, right? This is 4. My radius is the same as my hypotenuse of that triangle. It's going to be 4. Okay? This right here is going to be part of our side length, right? And this down here is our apothem. How can we find that?
Do we have to do SOHCAHTOA?
We do have to do SOHCAHTOA. Before we do that, though, we have to find the angle. Do you guys remember from what Mr. Cole was talking about how you find the angles, the central angles? Look back in your notes. What does it say? How do you find the central angle of one of these polygons?
It's on the front side. It's on the front side of the notes that we are currently taking. On the front side.
Dean, what do you got?
360 divided by the number of sides.
360 divided by the number of sides. Absolutely. Okay, we said our nonagon has 9 sides, right? So we've got 360 divided by 9. What? 40? Okay, so what's 40 degrees? Is 40 degrees this angle? No, right? 40 degrees is this whole angle over here, and we took half of that. So what do we really have in our triangle? 20 degrees. Okay, so now going back to what Chris said, we need to use SOHCAHTOA, right? So what do you guys want to find first? You want to find the side length there or the apothem? Side length? Okay. So we're finding x. So if we want to find x, which of our three, we need to use sine, right? Opposite over hypotenuse. Okay, so our that's going to give us sine of 20 degrees equals the opposite of our angle, which is x, over the hypotenuse, which is 4. How are you going to get x by itself? Times by 4. Those will cancel. So x is going to equal 1.37. Do a couple more decimal places when you're working with the trig functions, just because we want to be as exact as we can be. So we have 4 times sine 20. So I'd do 1.368. Okay, so that 1.368, did we find this entire side or just the piece? Just the piece, right? How are we going to find the whole one? Times it by 2. So if we want s, we're going to take our x we just found, 1.368, right? The side length, or the base of this little right triangle, and times it by 2. Okay, what'd you get there? 2.736. Okay, so we can fill in our s. We have 2.736. Okay, what's the last thing we need to find before we can use our area formula? A, right? The apothem. Okay, how are you going to find A? You could do Pythagorean theorem. It's not going to be quite as exact though, right? Because we rounded our side length. I agree though, you could do it. What's the other way you could do it? Morgan? Cosine, absolutely, right? You have the adjacent, or you're trying to find the adjacent, and you have the hypotenuse. So I would do cosine of 20 degrees. This is ca. Cosine of 20 degrees equals our apothem, A, over 4. Same idea as the last one, times by 4 to get A by itself. We take 4 times the cosine of 20, maybe. Did you guys get 3.759? ish. Yep. So our apothem is going to be 3.759. Okay, so now we have our apothem, we have our side length, the full side length of the nonagon, and then we have our number of sides, right, our 9. So we're going to plug that in. Area equals 1/2 A times N times S. Area equals 1/2. Our apothem we said is 3.759 times our side length, 2.736. I'm going to write it down here, times our number of sides, which is 9. Okay. I'm coming up here, area equals, what'd you guys get? Yeah, Allie?
46.28. You don't need to go farther.
Nope, I like 46.28. Okay? 46.28. Units squared. I think on the assignment they'll probably ask you to go to the hundredths place, but. Okay, anybody have any questions on that? Find the entire side length, okay? Find the number of sides and find the apothem, and then you can find the area.
Don't take the hard part, it's the 1/2 ANS. The hard part is finding that stuff, which we may have to do the Pythagorean theorem, potentially, or do some sine, cosine, tangent stuff, which we already know how to do. Okay? I think the thing that Mr. Wendt did great here is he drew out the triangle that we were using. This stuff gets difficult when we don't have a visual of the triangle that we're using to understand, okay, which one's the opposite side, which one's the adjacent side, which one's the hypotenuse. Draw it out, okay? There's no shortcuts on that. We just got to go to work a little bit. All right? I'll make a deal with you. We got 2 more here, and then I'm not going to do the back page. Okay? 2 more, and then I won't do the back page. It says a regular hexagon. Hexagon has how many sides? 6, thank you. Is inscribed in a circle with a diameter of 32 units. Find the area of the hexagon. All right, so I need my apothem, I need my side length, and I need the number of sides that I have. All right, we already know the number of sides, and that's 6. Okay, so if I look here, and specifically I'm going to look at this triangle that is given to us. Is this 32? What? Oh, it's the diameter, isn't it? So this isn't 32, but rather this is 16. Okay, now to find the central angle, which is going to be this angle right here, I need to take 360 divided by the number of sides, which is 6. 360 divided by 6 is 60 degrees, I think, right? That means this angle right here is 60. Does that go here? I need to divide that by 2, don't I? So that means this angle is 30 degrees. Okay? And I know that this is 90 degrees. What kind of triangle do I have here? (30, 60, 90 triangle. So I need the apothem, which sits right here, and I need this to get to the side length. How are we going to do this? Should we use sine, cosine, tangent again? You could, okay? We can use sine, cosine, tangent. But don't I know some characteristics of special right triangles? 30, 60, 90? Yes, I do. How do I know? Okay, if I have a 30, 60, 90 triangle and I have the hypotenuse, do I want to go to the long leg or the short leg? Short leg, absolutely. I'm going to pause. Okay, in a 30, 60, 90 triangle, what's our side that we want? That we always need if we don't have it? The short leg. Jen, did you say that? Thank you. We need the short leg. So how do I get from my hypotenuse to my short leg? Divide by 2. So that means this is 8. How do I get from my short leg to my long leg? Times by the square root of 3. Guys, we could have done SOHCAHTOA, but isn't that a lot easier? Again, you don't remember that. You get on a test, you don't know the shortcut, you can use SOHCAHTOA. That is an option, but I think that is a great resource for us. So now I know that my apothem is 8 times the square root of 3. And now my side length is... Better late than never, Joe. What's our side length? 8? Would you agree that this right here is 8, guys? So I need the whole darn thing, which is 16. So I've got everything now. My area is going to be 1/2 my apothem times the number of sides times the side length. 1/2. My apothem is 8 square root of 3. Guys, to be as accurate as possible, I'm going to write that in there. And then when we type it into the calculator, we'll figure that out. The number of sides is 6. And the side length is 16. Wait a minute. If this is 16, wasn't this 16? Which means that's 16. Is that right? Is that right or not? What's this angle, guys? What's this angle? 60. What's this angle? 60. That's an equilateral triangle. All the sides are 16 because all the angles are 16 or 60. Oh, turning it up in here. Here we go. In our calculator. Guys, for some reason I always do the half last. You can do it however you want, but I'm going to go 8 times the square root of 3 and hit enter. That's just that number. And then I'm going to times it by 6. And then I'm going to times it by 16. And then I need to times it by 0.5, or I could divide by 2. So 665 point, what is that? 1, 2. My label, square units. Okay, this one probably gives us our least amount of info. So to help us, I'm going to draw the center of the center of the whatever shape this is. How many sides does this have? It's got 10 sides. This is a decagon. So over here, I know my n is 10. I'm also going to draw this triangle to help us out a little bit. Do I know what my apothem is? No, I do not. Do I know my side length? Isn't that 7, guys? The side of that decagon is 7. So the only thing I do not have is my apothem. So let's look at this triangle. I'm going to cut this thing in half because I need it to be a right triangle. All right? So if I draw this out here, this side is this 7? It's half of it, isn't it? It's 3.5. Because the whole side is 7, so half of it is 3.5. Well, I need to find that angle. To find the central angle, take 360 divided by the number of sides, which is 10. And so that means this angle right there is 36. This angle needs to be half of that, which is 18. And so I need to find my apothem. My apothem is right there. It's not a special right triangle. I can't do the Pythagorean theorem. We have to do sine, cosine, tangent. So with respect to this angle, this is what side? Opposite. This is the adjacent. Opposite and adjacent is the tangent. So the tangent of 18 equals the opposite, which is 3.5, over the adjacent, which is A, my apothem. How do I solve for A? We're going to multiply both sides by A. So those cancel. So then I get A times the tangent of 18 equals 3.5. And then I want to divide both sides by the tangent of 18. So my apothem A is going to be whatever 3.5 is in our calculator, divide by the tangent of 18. Remember, our mode needs to be in degree mode. Otherwise, we will get the wrong answer. Isaac, what do we get there? 10.77. We agree with Isaac? Yes, no? Okay. And now lastly, my area of this decagon is 1/2 my apothem, which is 10.77, times the number of sides, which is 10, times my side length, which is 7. Guys, if we want to be a little bit more accurate, don't round this thing. We should have that exact number in our calculator, shouldn't we? So maybe start with that calculation. Take that times 10 times 7, times it by 1/2. If we want to be a little bit more accurate, don't round it when we're using it in the calculation. Our area is what here? Casey, what'd you get?
And typed it in.
Oh, I didn't type it in. Cam, what'd you get?
376.95.
376.95. Agree or disagree there?
I got 377.0.
That's what I got. Cam, did you round this? Did you use 10.77?
Yeah.
You did? I think if you use the exact number, you get this. Are they both right? Yeah. I think this one's a little bit better because it's a little bit more accurate. Our answer here should be units squared.